remember this.
Okay.
And that is parallel lines and transversals. Let's talk about it, because there's really only two things to remember. When you cut two parallel lines,
yeah,
you create 1, 2, 3, 4, 5, 6, 7, 8 angles.
yeah,
You only create 2 different angles. 1 and 2 are the only angles that aren't equal to one of those other angles. Okay, so that's all you have to remember, is that you create this angle and this angle that have to be supplementary to each other. And then every other angle is equal to one of those 2 angles. What's angle 6 equal to?
5?
Do they look equal?
Yeah.
6 is acute, 5 is obtuse.
6 and 8?
Again, 6 is acute, 8 is obtuse.
6 and 7?
Yes.
Okay.
In other words, to know what angles are equal here,
Yeah.
you know that you either have an obtuse angle or you have an acute angle.
Yeah.
So if I look at angle 5, what is angle 5 equal to, 1 or 2?
1.
Okay, notice the positioning. They're equal to each other. What is angle 7 equal to, 1 or 2?
Neither.
No, remember that every angle numbered here is equal to either 1 or 2.
Okay.
That's the whole point.
Alright.
So which is it? 7.
2?
Okay, because it's acute.
Yeah.
Okay, so can you see why 3 is equal to 6?
Yeah.
They're both acute. So every acute angle in this picture is equal to each other. And every obtuse angle is equal to each other. So if I bring back our picture, that's an acute angle. So is y.
Okay.
X is equal to y.
Alright.
X was 49.
Yeah.
X plus y is 98.
Okay.
Okay. At the end of that page?
Yeah.
Already? Okay. Close that one out. Open the new one. Let's see. I guess I need to, I'm not used to doing this. With this program. I have another program that does this for me. I guess it depends. I don't know what it depends on. Alright, let me blow this up a little bit. Okay, and you get lots and lots of questions about parallel lines. So knowing that thing about parallel lines is very important.
Yeah.
They are all disguised a little bit, like this one. In other words, not really. If you look at it, what are we looking at here? We're looking at these 2 lines are parallel.
Yeah.
Aren't they? Or let's see. Yeah, HC is parallel to GD.
Yeah.
And angle ABC, this obtuse angle here, is 100 degrees. So which of the following statements is false? Let's examine them. Oh, you already answered this one. Okay. Or did you? Is this your stuff down here?
Yeah, I did that. I just didn't. I don't know if it's right or not.
Okay. CBE is 80. That's correct because it's supplemental. DE F is 80 because it's acute, which means it's equal to every other acute angle you see here. Angle DEB and CBE are corresponding angles. DEB and CBE. They are not corresponding angles. So that's correct. And the last statement, CBE and GEB are alternate interior angles. That's correct also. That one and this one. Okay. Okay, want to take a shot? Which of the following statements, there's only one of them that's true?
Okay.
This line is equal to this line, and this line is equal to that line.
Okay.
What else do you know about those two triangles? Besides those two pieces of information.
They're corresponding?
No. What else do we know whenever you have two crossing lines? What do we know about that? In other words, when I have two crossing lines like that, this angle is equal to that angle, and this angle is equal to that angle.
Okay.
So what do we know about this figure? What about these two angles here?
They're equal to each other?
Okay. So now we have this side's equal to this side, this side equal to this side, and this angle is equal to this angle. So what can you say about the triangle?
Side angle side?
Correct. So number C. Hold on. What's the difference between B and C? TUV VWX. Oh, I see. Okay, well maybe we better re-examine this. In other words, it's true that this triangle is congruent with this triangle, but how? In other words, they're going to force us to name it right. Hold on, let's talk about that, because we haven't really talked about that a lot. Naming it properly. In other words, when we name the triangle, it orients it properly. So I'm going to draw these two triangles separately here. And I want you to name them for me. If this angle is equal to this angle, and this side is equal to that side, and that side is equal to that side, there's our side angle side.
Yeah.
What's the lettering on the one on the left?
Wait, what do you mean?
Well, in their answers, notice that the only difference between C and B is B says TUV is congruent to VWX, and this says TUV is congruent to WXV.
Okay.
In other words,
I think C is the right one.
well, let's, okay, this is clearly PUV. And when I say clearly, I don't mean clearly, I mean we can go left to right, and V is right there. In other words, this angle being equal to this angle means this is V up here. So the question is which side goes here, what letter goes there and what letter goes there? Is it W on the left or X on the left?
X is on the left.
Actually, it's W. The reason is hold on a moment. Okay, I think I have this wrong actually. TV, that's this line here, is equal to WV. I got it backwards. You were right. X is on the left.
Okay.
And that makes C the correct answer. In other words, we can start the name of the triangle at any vertex. And what C says is that TUV is congruent to WXV. So we want to start at the same points. And the only way I know is that it says TV, this line here, is equal to WV. And UV is equal to XV. So, alright, so it is C, not B.
Okay.
Though I don't particularly like that question because, well, I just don't think that it's that important to know that. And, you know, that's probably heresy in the geometry world, but knowing the triangles are congruent is a different matter altogether. That's very important to know. But knowing how to letter them, I guess that is important. It's probably more important than I think. All right, so number 6. ABD is congruent to CBD. Name the theorem or postulate that justifies the congruence.
Is it side, angle, side?
Which sides, which two sides are the same?
The middle line and the outer one.
Okay, the middle line is equal to itself, that's true. But there's nothing in this picture that says AD is equal to CD. Now, you can infer that, you can figure it out, because this angle is equal to that angle, which would make this triangle isosceles, and it would make this side equal to this side. But even still, we wouldn't have side, angle, side. We would have side, side, angle. So we don't want, which, in other words, we know a few things here. And not much else. That's a right angle. And this angle is equal to this angle. So what do I know already? I know two angles are equal.
Yeah.
In other words, if this is a right angle, this has to be a right angle. So this angle is equal to that angle, and this angle is equal to that angle, which automatically makes this angle equal to this angle. But there is a postulate that says angle, angle, side. Side BD is equal to itself.
Yeah.
And we have angle, angle, side here.
Okay.
Now we can't really use the hypotenuse one because they didn't tell us that this hypotenuse is equal to that hypotenuse. Okay, let me open another page. Where can we start here?
Well, isn't the angle right next to 96? Isn't that 96 too?
No. What is that angle? That is the key to solving this problem. What's the relationship between 96 and x?
Does it have to equal 180?
Right. So what is x?
Okay. 104.
That would equal 200.
Oh yeah.
Let's try 84.
84.
Okay. Now let's look at the triangle. What kind of triangle is that?
Isosceles.
Okay. So what does that mean about angle y? What is it equal to?
84.
Correct. These kind of geometry problems, this is the way you do almost all of them. You just start figuring out stuff you can figure out and then figure out the other stuff. What's that leave x equal? These two add to 168.
12.
Huh? And so that's the answer is D. X equals 12, y equals 84. Now notice one other thing that's worth pointing out as long as we've got this picture drawn here. This ulterior angle, which is the 96-degree angle, is always equal to the sum of x and y. In other words, it's always equal to the two angles of the triangle that it is not next to.
Okay.
Notice that it's 96 and 12 plus 84 are 96. So I could have answered this question in one step had I applied that. Since I know that 96 has to be equal to x plus y, D is the only answer that fits.
Okay.
And that's worth knowing. And of course the reason it's that way is because if I draw angle Z there, 96 degrees is supplementary to Z, right?
Yeah.
Well, Z is supplementary to the other two angles. In other words, because the sum of the angles has to be 180, then the third angle of any triangle is always supplementary to the sum of the other two. So if I've got Z supplementary to 96 and it's also supplementary to these two, then these two must be equal to 96.
Okay.
Another parallel line and transversal. Like I said, you're going to run into a lot of these, so let's make sure we get these right. L and N are parallel. Let's go through each of these, because this is another one of those questions where which is the wrong answer.
Okay.
So, is 8 equal to 2?
No. Wait, yes.
Because they're both the acute angle.
Yeah.
Is 2 equal to 6?
Yeah.
Is 5 equal to 3?
No.
Aren't they both obtuse?
Yeah.
They have to be equal. You don't have to do anything else but tell whether these things are obtuse or acute.
Okay.
Now, unless they give you a problem like the following, if they give you something like this, and they draw a vertical line through it, then all 8 angles are 90-degree angles, so all the angles are equal to one another. But if they draw a line that is just slightly not vertical, you still have an obtuse angle there and an acute angle there. And as long as you can tell what's obtuse and what's acute, That's all you need to know. And that O plus A equals 180.
Okay.
In other words, the obtuse and the acute angle always equals 180. So whenever we see a picture like this, gosh, I can answer every single thing instantly without figuring out whether it's alternate exterior or alternate or corresponding. None of that stuff matters. The only thing that matters is, are we looking at an acute or an obtuse angle?
Okay.
And even though this is drawn with some perspective, in other words, it's easy to look at this picture and think of it as these are all right angles. And it just looks like an acute angle because of the perspective. In other words, we're looking at it from an angle. In other words, this could be three strings all perpendicular to one another.
Yeah.
But forget that. Forget their attempt to fool you. All you have to do is determine whether that's obtuse or acute, irregardless of perspective. Well, clearly 2 is acute, and clearly 1 is obtuse. And just as clearly, 3 through 8 can be determined that they're either acute or obtuse. So clearly 7 is not equal to 4 because 4 is acute and 7 is obtuse. More parallel line questions. You want to do good on this test, make sure you know your parallel lines.
Okay.
Which theorem guarantees L and M are parallel? Okay, you got to know a little bit more than what I just said, because for this question you do have to know those names.
Because of D.
Are these exterior or interior angles?
Exterior.
Very good. And you're right, it is D.
Okay.
See, I don't even like that they have 4 different theorems.
Yeah.
I mean, don't you think that's a little silly? Why don't they just have one theorem? You have an acute and you have an obtuse angle, and every angle is one of those. That's one theorem. Well, I don't think they need a theorem for alternate exterior and then alternate interior and corresponding, all of those. It just seems, why confuse a student like that?
Mm-hmm.
All right, looks like we're going on to other stuff here besides parallel lines. Okay. Number 10, what is our first step? It's the general format of it.
Put it in slope-intercept form?
Not quite. What is slope-intercept?
Like y equals mx plus b.
Okay, so that's our standard. What do we need to make an equation?
The slope.
Okay, that's a good starting place. We also need b. In other words, a proper equation would look like this. In other words, we don't need x or y. We need m. We need to solve for m and b, always with these. What is m? What is the slope of our new line? Not what is the slope of our line going to be?
So
because it's parallel to this line.
Yeah.
In other words, that's not the equation of our line.
Okay.
The equation of our line goes through a different point. but the fact that it's parallel to this line says a lot about it. What does it tell me? About its slope.
It has the same slope.
Okay, so it's -8.
Okay.
Okay. Now, let's figure out the equation of our line.
Okay.
How do we do that?
We have to find B.
Okay. So let's start with what we know. We know this much. Our slope is -8, and we need to solve for B.
Yeah.
And we have a point that it goes through, 7, -2.
Yeah.
So what do I do next?
You have to plug those into the equation.
Uh-huh.
So -2 equals -8 times 7 plus B.
Okay, solve that for B.
Is it -56?
Uh-huh.
Okay, so -2 equals -56x plus B.
No X. You already plugged in. You
No.
substituted for the X. If I throw an X in there, it's just going to really throw things off. Remember, we need a number for B. If I got an X in there, I can't get one.
Yeah, okay.
So what's B?
So then you add 56.
So what's B?
B equals 54.
Okay, so what's my equation?
Y equals -8x plus 54.
Number C. Yes.
C.
So a variation of this, which I'm sure is coming up, is they might also say, what's the equation of a line that goes through this point and is perpendicular to this line? How would I start that? What would the very first thing I would know?
Wait, what?
Well, let's just wait till we get to it.
Alright.
What's the slope of the line? What is the slope of a line perpendicular to this line? What do we have to do to figure that out? We have to know two things. First of all, we have to know what the slope of this line is.
Yeah.
Second of all, we have to know, well, what's the slope of the perpendicular line going to be once I know the slope of this line? So what's the slope of this line?
-2.
No. Remember, y equals mx plus b. M is the slope. So we got to get this thing into y equals mx plus b before we can tell what the slope is.
Okay. So 9y equals I don't know, is it -2x?
What do I have to do to get rid of the -2x on the left side of the equation?
Add 2x?
Okay. So it's positive.
Yeah.
Okay, now what?
Divide. Do you try to get the y by itself?
Yeah, we're trying to get it into y equals mx plus b format. If we can get it into y equals everything else, we'll know what the slope is.
Yeah. So divide by 9?
Okay, so tell me what to write.
Y equals Is it a fraction?
Uh-huh.
Ooh, I don't know.
Divide every term you see by 9.
Okay.
What do you have?
Um,
In other words, I'm dividing that by 9, I'm dividing that by 9, and I'm dividing that by 9.
okay.
So what does that leave? Y equals what?
2/9.
What's the slope of this line?
Is it...
This line, right?
Wait.
This line right here, what's the slope of that line? The one we just solved for.
10/9?
No. Y equals mx plus b. So if y equals 2/9 x plus 8/9, what's the slope?
Yeah.
What is m?
I don't know.
Hold on, Julian. There's our equation. Y equals mx plus b.
Okay.
Only here's the equation we're looking at. Y equals 2/9 x plus 8/9. What's m?
Okay. 2/9?
Yes.
Okay.
Okay. So the slope of this line is positive 2/9. Okay. But they don't want the slope of that line. They want the slope of a line perpendicular to this line.
Okay.
So how do you get the slope of a perpendicular? It's 2 words.
You gotta flip it and then like minus it.
Okay, it's called the negative reciprocal.
Negative reciprocal.
Remember it as negative reciprocal, you'll know you have to do 2 things. You got to make it opposite sign and you got to flip it. So what is the slope of the perpendicular line?
-9/2.
And that is answer C.
Yeah, okay.
And a lot of these, it's helpful to look at the answers, because if you look at the answers, you know the slope's either 2/9 or 9/2, right? So when you were struggling back here, trying to figure out what the slope was, if you peek at the answers, you would know right away that it's 2/9. You would spot that. You would figure it out. And the y-intercept is 8/9.
Yeah.
But they didn't ask about the y-intercept. The only thing they're really asking in this whole question is what's the slope of this line and what's the slope of the line perpendicular to that line.
Yeah.
All right. How do we do 12 here?
You got to... I don't know.
Well, like with all geometry problems, what do you know? What can you figure out? In other words, I don't mean that facetiously. I mean, on this problem here, what can we solve for?
Can you solve for x?
Well, not immediately.
Okay.
And rarely is it such that you're able to solve for your answers immediately. That's just not the way geometry works. In other words, all your geometry problems are going to be problems where you have to solve for a couple other things before you can solve for your final answer.
Yeah.
So what do we know about this triangle right there? Do we know any of those angles?
Yes.
What? Which ones? What's this one?
Wait, so it has to be parallel.
Oh, there's no parallel going on here. That's not what these arrows mean.
Okay.
And
So those two angles have to equal 88, right? So it's 44?
no, they have to equal 180. That's what you meant to say.
Oh. Oh, yeah.
Okay, so that's 92.
92.
Okay, what's this one down here?
92? Oh, wait, no. 53?
Yeah, now let's talk about something. There's a skill you need in geometry, repeatedly, over and over and over and over. And that is how to subtract the number from 180. Correct?
Yeah.
Right?
Yeah.
Okay. So let me show you how I do it. Because you're not always going to need a calculator to do this. When I look at that 127,
Okay.
I know that the answer, the number here has to be a 5.
Yeah.
Because 5 and 2 have to add up to 7, not 8, 7.
Yeah.
Because there's going to be change. And these two numbers have to add up to 10.
Okay.
So instantly I know 53, and then I do a check, looking back at adding them together to make sure that they add to 180. That's the way I do it.
Okay.
But seriously, if you can come up with a little trick to subtract from 180, it's very, very helpful.
Okay.
Rather than always having to do this and going through the typical way of doing it. If you get good at doing it, it'll save you gobs and gobs of time. Now, the way I got 92, I know that if this is 90, this would be 90, right?
Yeah.
Well, this is 2 short of 90, so this has to be 2 more than 90. So I didn't do the same math there. I did a different technique. But it's okay. The technique I use doesn't matter. Whatever gets you to the number accurately and quickly is what you want.
Yeah.
Okay. What's x?
X is 35?
First of all, look at it. I like the math.
Oh,
I like the math that you did.
Okay.
X isn't 35 though.
Yeah, that third angle is.
Third angle is. So if this is 35, what's x?
Oh, alright, I knew this. 145?
Okay. But you just did 2 unnecessary steps. Remember the ulterior angle is equal to the sum of the other 2?
Yeah.
So you figured out that this one was 35 based on the fact these were equal to 145, right?
Yeah, and I already knew it was 145.
Right. So there's no point to do that calculation twice.
Yeah.
In other words, if you can remember that that ulterior angle, that exterior angle is equal to the sum of the other 2, not the one next to it, then it saves you a step always in figuring out that angle, especially on a problem like this. And you have to do this problem in this manner. In other words, there's really no way to get x immediately. You have to get this angle and then this angle. So there's at least 2 things you have to figure out before you can get x. Then you have to add them to get x. So it's actually 3 steps, and that's the way almost all geometry problems work. You don't expect to be able to figure out x immediately without figuring out something else first. Okay? Just assume that, and that'll help you because you won't be looking for the answer in one step.
Yeah.
What's x here?
X is...
Take me through the process. How are you figuring it out?
So you have to find the second angle, the not x. So you have to see what adds to 180. So 63 is that one, right?
It's close. Oh, this one. Yes.
Yeah.
Okay.
So and then
So that's one. Hold
you
it.
have to find
Let me write this out. That's one step. What's next?
Yeah. Then you add 66 and 63.
Okay, that's 129. That's 2 steps.
Yeah, and then 51.
Okay, 3 steps.
Yeah.
However, I can turn it into a 2-step, maybe even a 1-step problem.
Okay.
I can. I know that x plus 66
Yeah.
equals 117.
Yeah.
Immediately subtract 66 from both sides.
Okay.
X equals 51.
Okay, yeah.
So we're seeing problems where it's useful to know that that's equal to the sum of these two.
Yeah.
Because you save yourself at least 1 step, maybe 2. A lot of times.
Okay.
Hold on. Find the measure of the interior angles to the nearest tenth. How am I going to do that?
Ooh, I don't know. You have to add all those equations together, right?
Okay, so tell me what I should write as step 1.
So 3x plus 2 plus 4x plus 2 plus x minus 1 equals 180.
Correct. Now, I didn't use parentheses there because I was doing nothing but addition. So I didn't need them. If you're ever doing...
Okay, so if you were to multiply, would you use
Yes, or if I would have had subtraction going on at any point. I mean, I got a negative sign there, but that's okay, because if I would have used parentheses, because I'm adding it, and I remove the parentheses, there's nothing that changes. That's why I didn't need to use parentheses, because I'm adding 3 angles together.
Okay.
Other problems are different. If you're subtracting binomial terms like this, then you do need to use parentheses, but only when subtraction is going on. Okay, now help me solve this. What's next step into solving that equation?
You add all the like terms together.
Okay, so what's the next line?
8x plus 3 equals 180.
Okay. Next.
So minus 3.
Okay, so
From each
8x equals what?
177.
And you might need a calculator for this. What is that number? And it says round off to the nearest tenth. All of our answers are to the nearest tenth. So let's talk about this for a second. We're rounding off before we're getting this angle, right? You're going to give me a number for 177 divided by 8. What did you get in your calculator?
22.125.
22.125.
So 22.1.
Well, if we round that off to 22.1, then that round-off error is going to get magnified. Because in order to figure out what this angle is, I have to multiply x times 3, and then, what is that, add 2? So I don't know if you can see that or not, but if we round off early in a problem, you create round-off error. It then gets magnified. In other words, if I round that off to 22.1 right now,
Yeah.
now let's figure out what 3x minus 2 is.
Okay.
What is it?
So, wait, I'm confused.
Okay, we solved the equation for x. We didn't solve any equation for these angles yet.
Okay.
So all we did was we set all of these angles equal to 180. That gave us a value for x. Well, what's this angle? It's 22.125 minus 1.
Yeah.
Okay.
Oh, 21.125?
Okay. I guess D is the answer, huh?
Yeah.
Because it's
So
the
you
only one that has a 21.1 in it. So I can't really illustrate my, maybe I can. So we know this angle here is 21.1. What's this angle up? And let's do this one here. Because this magnifies the error the most.
Okay.
So we've rounded this number off. Now multiply that by 4 and subtract 2.
Okay, so 86.1?
If I multiply it by 4, it turns into 88.4.
Oh, 88.4.
So 86.4, right?
Yeah.
Okay, so I would expect that as one of the angles. However, notice that if I don't round it off, or if I leave it to more places, and I multiply this by 4, I get 88.5. Now I subtract 2 and I get 86.5.
Yeah.
Which is the correct answer? 86.5 or 86.4?
Yeah.
Which one is correct?
86.4.
No?
25?
Uh-huh. In other words, this is the more accurate one, right? I use more places.
Yeah.
In other words, I took this out to 3 places, multiplied it by 4. 4 times 0.125 turned into a 0.5.
Okay.
And now it changes the answer. The final answer becomes 86.5 instead of 86.4. This is not correct because this has a round-off error that got magnified by a factor of 4. When you rounded this off to 22.1, you dropped those two numbers right there.
Okay.
And then when you multiply it by 4, you get 86.4, not 86.5.
Yeah.
But the truer number is 86.5.
Yeah.
And that must be 4x plus 2. Right?
Yeah.
Okay, it looked like minus on my screen. So 4x plus 2 would be 90.5, not 90.4. They gave the correct answer in their answer.
Yeah.
Because they did not round off early.
Okay.
This is an excellent problem to demonstrate why you should not round off early. Because when you do, you take the error that you generate by rounding off and you magnify.
Yeah.
All right. What is the measure of each base angle of an isosceles triangle if the vertex angle is 40 degrees and its two congruent sides measure 25 each? So the base angles is that angle and that angle.
Yeah.
What are they equal to? Since they only give one answer, they must be the same, huh?
Yeah.
Okay. So what are they? They're the same because it's an isosceles triangle.
90.
Add them all up and see if that's 180.
Okay. So
That answer isn't on there also.
60?
That answer's not on there.
Oh. Well, it's not 40, so...
Okay, you're correct. It's 70.
Yeah.
Because
Okay.
70 plus
Oh,
70
yeah.
is 140, plus 40 is 180. But let's figure out how to do that algebraically. In other words, this is also an extremely common problem, where they give you an isosceles triangle, and they give you this angle, but they don't give you these two.
Yeah.
Well, what do I know about those two? If I call that one x, then I'm going to call that one x because it's the same.
Yeah.
Based on that. Okay. Now, the way to solve this problem is what? What equation can I write?
40 plus 2x equals 180.
Okay. Solve that. Next line.
40 plus... Oh, minus 40 from each side.
Okay, so what's the next line?
2x equals 140.
Okay, and then finally...
And 70. X equals 70.
That's how you solve that problem.
Okay.
Okay, so before we go to another one, let me give you the same problem, only I'm going to change that number. Now what is x?
60.
Good. Okay. Now let's do one more. Now what is x?
Is it 75?
See what I mean? That you have to get good at subtracting from 180?
Yeah.
You have to do it on almost every single geometry problem you encounter.
Yeah.
So the better you get at subtracting a number from 180, the better you're going to do at geometry.
Yeah.
All right. Let's call it a session.
Okay.
And let's see, we have another session soon, don't we? No? It's not until next week. Yeah, I guess next Monday night.
Yeah.
Monday at 8.
Okay.
Talk to you then.
All right. Bye.
Yep.
Thank you.
Sure. Okay. Talk to you later. Bye-bye.